Hi guys, welcome to today's chemistry class for SS1. In today's class, we will be treating elements, but we are going to be taking part 4 of this topic. So, before we proceed, let me tickle your fancy a bit. If you are not part of the solution, then be rest assured you are part of the precipitate. You get the drift? Lesson objectives. At the end of this class, the student should be able to define isotopy, differentiate between isotope and isotopy, calculate the relative atomic mass of an isotopic. And so, let's get rolling. What is isotopy? Isotopy is a phenomenon whereby atoms of an element exhibit different mass numbers but have same atomic number. Don't forget that the atomic number must remain the same for the element to be that element. If you change the atomic number, then you have changed the element. So long as it will remain the same element, then the atomic number must be the same. Now, the difference in mass number is due to the differences in the number of neutrons present in the nucleus of these atoms that display isotopy. Such atoms are known as isotopes. Hence, isotopes are atoms of the same element with the same atomic number but different mass numbers. Isotopes of an element have slightly different physical properties but exhibit the same chemical properties. This is because neutrons contribute only to the mass of an atom, not to its chemical behavior. The mass spectrometer shows the relative abundance of isotopes in the environment. The relative atomic masses of elements are the mean weight of the masses of the isotopes of the atoms of that element. Meaning, if the element has more than one isotope, like hydrogen that has 3, the average mass that we take will be a mean weight of the 3 masses. So, let's take a quick example. Example 1. Chlorine exists in 2 isotopic forms, chlorine 35 and chlorine 17, respectively. The relative abundance of chlorine 35 is 75%, and that of chlorine 37 is 25%. Calculate the relative atomic mass of chlorine. Solution. We multiply the masses by their percentage abundance. So 35 times 75 plus 37 times 25, all divided by 100. This will give us 2,625 plus 925 divided by 100. Going further, that will give us 3,350 divided by 100. And if we do that, our final answer will be 35.5. That will be the relative mass of chlorine. Example 2. A naturally occurring sample of lithium contains 7.42% of lithium, 6 and 92 0.58% of lithium-7. The relative mass of lithium-6 is 6.015 and that of lithium-7 is 7.016. Calculate the relative atomic mass of a naturally occurring sample of lithium. Solution: 7.42 times 6 plus 92.5 times 7 divided by 100. This will give us 44.2 plus 647.5 divided by 100. This will end up giving us 691.7 divided by 100, and then the final answer will be 6.92. Example 3. The relative atomic mass of an element is 21.5. The two isotopes of the element are E20, occurring at 25% in nature, and EX, occurring at 75% in nature. Calculate the value of X. Solution: 20 times 25 plus X times 75 divided by 100 will give us 21.5. Breaking that down, we are going to have 500 plus 75x divided by 100 to give us 21.5. Then 75x will be equal to 2150 minus 500 divided by 75. X will now be equal to 22 at the end of the evaluation. Summary. In this lesson, we talked about isotopy, mass number, we calculated the relative atomic mass, and then isotopes. It's now time for us to take an assessment to see how well you have studied. Question 1. Which of the following statements is true? A. Isotopes have the same mass numbers. B. Protons do not add to the mass of an atom. C. Electrons have no mass. D. Neutrons have no charge. Question 2. Which of the following causes isotopy? A. Atom. B. Proton. C. Neutron. D. Electron. Question 3. An element that displays isotopy is called A. A compound. B. Isotope. C. Proton. D. Atom. At this point, we have come to the end of today's lesson. Thanks for watching and see you in the next lesson.